In this lesson, we focus on mathematics, Math 142, kinematics of a particle. We shall study equations of motion and their applications. Right, focusing on third questions, we shall focus on this particular question here. And we are told here that the water sprinkler positioned at the base of a hill releases a stream of water with a velocity of 15 meters per second, as shown. Determine the point B where the water strikes the ground on the hill. So when we need to determine, right, the point B where the water strikes the ground, right, on the hill. Assume that the hill is defined by the equation y equals 0.05 x squared meters, and neglect the size of the sprinkler. Okay, and we have exactly this kind of a situation here. So there are certain kinds of equations of motion that we're gonna obviously focus on at this point. But now we are told here that the water sprinkler position at the base of a hill releases a stream of water with a velocity of 15 meters per second. Right, so if the velocity is actually exactly 15 meters per second, it means that we have a couple of things. So we can view ourselves as having, for example, the certain velocities, right? We have certain velocities, like we have the velocity at the beginning, and we have now this velocity at the beginning that is given can actually be determined, and it can be determined very, very precisely. But how precise can we actually be in a position to determine that? So you can say, for instance, we can determine V, let's call it V. Right, let's call it V0x. Because immediately when this is projected at that angle, there are a couple of things that we can obviously take into account. There are certain components of this, and the angle is theta. So that now the components here are that immediately when this is projected, there's going to be some velocity v0x, and there's going to be some velocity v0y in the y direction. The v0x is going to be given as follows, right? So the v0x is going to be given by what, right? It's going to be given by 15 cosine theta, and this is actually 15. All right, you can just say 15 cosine 60. Right, so it's actually 15 cosine 60 degrees, which I'll get the answer. Then there's also V0y, which is 15 the sine of 60. V0y. Right, so which means that you shall have 15 times cosine 60. Right, and this is actually exactly 7.5. So we shall have 7.5 meters per second for the velocity in the x direction, and then the velocity in the y is going to be given by 15 the sine of that. The sine. I hope I actually have punched that incorrect. Yeah. So here we're going to also have 15 the sine of 60, and 15 the sine of 60 is actually 12.99. So we shall have actually that one, which is actually 12.99. So this one will be 12.99 meters per second. So these are sort of the velocity we're getting. Okay, now, then we need to consider the the fact that as it moves like this, as the water moves, because we have the water sprinkler, now there is what you call horizontal motion. So we shall consider horizontal motion of the water, obviously, because now determine the point where the water strikes the ground. But the water, when it moves like this, it progresses horizontally, but also it actually is, it has what you call vertical motion. Right. So let us reason this out together. So if we have both the vertical and horizontal motion, right, what are the implications of this? So looking at the horizontal motion, we shall use the equation of motion x equals x naught plus v0xt. And this means that x equals x naught. But obviously, if we say it starts at the origin so that we have 0 there in the beginning, and then simultaneously we have the v0x, which is like exactly that one, you can call it 7.5t. This means that x is 7.5 multiplied by the time. But also you have the fact that as it begins to move like this, there is what we call vertical motion. Right. So now looking at vertical motion, right, we have exactly the following here. Right. Okay. Now this is going to be our horizontal motion. And if this is going to be our horizontal motion, there's something we need to take into account. It is the fact that we know that our y, for example, is 0.05 x squared, 0.05. Our x is 7.5 t, and you square that. Okay, substitute here. And now we're going to actually get the answer to this substitution. And if you do that, you'll have exactly 0.05 times 7.5 squared. And then this becomes 2.8125. 2.8125. So we're getting exactly 2.8125 t squared. Okay, so this is sort of what then we are actually able to obtain as this particular function here. But now with this, this is about the horizontal motion. And then we need to obviously now investigate the vertical motion. Let us look at vertical motion. Right, so looking at vertical motion, the couple of things that we need to take into account here as a matter of fact, and let us begin to investigate these very, very accurately and see what we need to get. Right, so this becomes the following. So for the vertical motion, we shall have y equals y0 plus v0 yt plus 1/2 ac t squared. Right, so at this point, we take note of the fact that this is actually what we're going to have, where our acceleration itself becomes constant. But now let us reason these together. So we're going to start and understand these as follows. So we're going to say, for instance, we have y. Now the y is 0, beginning from the origin, and then the 15. This one, we saw that it is 15, the sine of 60, t. And then it is that this acceleration because this object is actually obviously moving upwards, but we understand that the acceleration is actually obviously towards the ground. Okay, I want us to understand this very, very carefully. So now the couple of things that we need to take into account here as a matter of fact, it is that when this particular object is moving in that particular manner, and we need to consider the aspect of its acceleration, right? And the acceleration we shall be determining. So, and everything, this is actually in meters per second. So if it is in meters per second for us, it would actually mean that you are considering the vertical motion, and considering the vertical motion as and the acceleration that is always downwards. Now, obviously, let's pause here to reason together. So if we are here and we're saying that this, if an object is moving upwards, so you choose the direction. So in other words, if you choose, we choose upwards as positive, right? Because the 15 would have a component that is upwards, meaning it's going to be positive because the velocity is obviously upwards here. But you understand that the acceleration, which is constant, it's going to be actually downwards, right? And so if it is actually downwards, it means that as much as the velocity is positive, but the acceleration is downwards, and therefore it is negative. So you're going to have minus 9.81. And now, obviously, we're looking at this in meters per second, but it can also be done in feet as well. Right, in feet per second. Right, and with this determined, then this is actually exactly t squared like that. So we have got this one, which is 12.99 for the 15 sine 60 is 12.99. So you're going to have actually 12.99 t, and we have this here. Okay, so yeah, we can do this one with the calculator just to make sure that we get the correct answer. So that in the end, what we're getting is 0.5 times 9.81. And we have exactly this, which is 4.905. 4.905, which is 4.905. Let us write clearly to avoid mistakes. 4.905. Then we have exactly our t squared there, like so. Upon careful examination, what actually do we have here? We need to remember that therefore this gives us an equation we can call equation 2, but we actually have got another equation here from the horizontal motion we can call equation 1, but now y is equal to this. So from equation 1, we know that y is 2.8125. We know that y is actually 2.8125 t squared. We called this one the first equation. So now if they're equal, so 1 equals 2.8125 t squared, which is 12.99 t minus 4.905 t squared. Okay, now you add everything up, because when you add everything up, this one and this one are like terms, so you're going to add them up. And then if you do 2.8125 plus 2.8125 plus 4.905, 2.8125, 4.905. And what we're getting is 7.7175, 7.7175. Right, so we're getting 7.7175 t squared minus 12.99t equals 0, which is 7.7175 t squared minus 7.7175 t squared minus 12.99t, 12.99t, and this equals 0. Okay, and then now we can factor out t as a common factor, and we have 7.7175t minus 12.99, and this equals 0, which means we shall have that time equals 0 at the origin, or we shall have that time is 12.99, and then you divide by 7.7175, and therefore we shall use a calculator to get the time here. Shall use a calculator to get the time here, and the time is gonna be exactly 12.99. You divide by 7.7175. See what we're getting? We're getting 1.68 is the time. So we're getting 1.6832. 1.6832. Right, we're getting 1.6832. So we're getting 1.6832 seconds. Right, and once you get this, then we actually need to get the coordinates. So which means that we need to recall what we got. So we got that our x is 7.5t. Our x is 7.5t. And the t is 1.6832. Let us check what we're getting here. So if you use our calculator, so we have this one. So we're going to multiply these by 7.5. 7.5, and then this is what? It is actually 12.62, which is the x component. 12.62, which is the x component, which means therefore we have here that this is 12.62 meters. But we're not done. We also need to get the x and the y component, but you already know the y component, so we spoiled for choice. We can use this one. Right, we can use equation 1, which is 2.8125 t squared. Right, it is 2.8125 t squared, and this is 2.8125 t squared. What is the t? It's this one. You can put, yeah, okay, you can put this one, you can put this one for the t. I'm going to put a more accurate result, which is 12.99, 7.7175, and then you're going to square this, and it's approximately what we're going to get. So, right. So we're going to have, let's see, if you're going to do 2.8125 open bracket 12.99 7.7175 and then you close. Okay. And then now, what we're then getting the y to be, oh, there's a square. Did I put the square? I did not do the square. Okay, I did not do the square. Let me see. Let me punch properly. 2.8125, open bracket, fraction, 12.99, 7.7175, close bracket, squared. Right, it is actually exactly 7.97. 7.97. So you have actually exactly 7.97 meters. And obviously assume that the hill is defined by the equation, neglect the size of the sprinkler. So the answer is this. We determine the point B. And so this means we can say hence the point B, which has the coordinates X and Y, is actually the point B where X is this one, 12.62, 12.62, and the B, the Y component, is 7.97 meters. Right. So what we're going to do then, it was awesome having this discussion right now. I know that we have obviously taken a little bit of time, but let me see. I think that maybe with your permission, I can right. I think that this is pretty much very, very sufficient for today, depending on your case.